Hi everyone, my name is Abhishek Kumar Sastry and this is a project which I created for my machine learning course at University of Maryland. Uh, this course is about bacterial colony classification using a convolutional neural network. The primary idea behind this is that it is extremely easy nowadays to get your hands on a cheap but powerful microscope from the market. Uh, but still, it requires experts' knowledge to actually understand what is being observed. For this, I came up with the idea to create an app which can actually do that for you. Okay, the first step in this process is to actually have an algorithm that can actually recognize the bacterial colonies from the images. Now, with respect to this, there are very few databases available on the internet. One of the most popular one is the DBAS database, which contains about 660 images for 33 different species. Um, as you can see, that some of these bacterial species are pretty much similar to each other, and also that the number of images is too low. So it is not an easy task to come up with an algorithm that can perform well on this database. So let me first go through the code step by step so that you can understand what is going on over here. Uh, Primarily, I use the Keras with TensorFlow backend on Python for this project. So first here I am importing all the images and into a giant list and their indexes into another list. Through this process, it is obvious that the images will be stacked one after the other in the increasing order of their indices. So it is important to shuffle the images before using them further. So here I shuffle them by using the zip function in Python, and as observed here, the images have been shuffled and imported properly. In the next step, I divide the entire set of images into the train and the test set. The around 15% of images are used for test of the network. In the next step, I convert the indices to categorical, as I'll be using the softmax function in my network. Here I basically create the convolutional network for training on my images. So let me first go through the architecture of that network. Um, as you can see, basically the convolutional neural network contains 4 CNN layer with the number of filters decreasing as you go deeper into the network. Finally, the network is flattened and there are 2 dense layers with 120 and 64 neurons respectively. The reason behind this is that since the number of images are pretty small, it is extremely important to prevent overfitting. With respect to that, one of the rule of thumb is that the network should have a small number of parameters to train. And if you observe the network summary over here, the number of trainable parameters is primarily controlled by the dense layer which happens to occur just after flattening the network. So for this, it is important to have the convolutional layer which is just before the flattened layer, to have the lower number of output parameters. So for this, I used a high resolution image. So for that, the first layer has about 32 filters, which of 2x2 size. And as you go deep into it, I decrease the number of filters so that the final output just before the flattened layer has a lower number of parameters. Okay, so after getting the network, I use image augmentation to increase the number of training size, and these parameters are found to work best through trial and error method. It took about 90 to 100 epochs to reach about 60% accuracy on the training set, and when the network is validated on the test set, as you can see, I get about 65 to 70% of precision recall F1 score, and also a 67% accuracy. So this shows that the network performs fairly well, means even the data set was extremely small.